I'm Benny Cohen.
I'm Natalie Lockey.
I'm Natalie Brave.
And I'm Adam Kalman.
And we're here to show you our project we worked on with the TI-Innovator Rover. As you can see, we made a modification to this robot to add a pen to it.
The rover performs Newton's method and variations of Euler's method, which finds zeros on a graph. You can input a guess for your x, and then we wrote some code, which we're about to explain, that does its best to find that zero.
We started the program by asking the user to input a function, and then we had the rover graph that function step by step, so we just went through a series of x values. And then for Newton's method, we asked the user to input a first x coordinate guess, and then the number of iterations they want the program to run. So then the rover will go down to the x coordinate that you inputted on the graph, and then from there it'll take the derivative at that point to draw a tangent line back up to the x-axis.
So we noticed that the visual representation was slightly shifted. And we asked ourselves, why is this happening? And we realized that the way these wheels are built, it causes a lot of shifting, especially when the rover rotates, when it's doing Newton's method. So we needed to make some adjustments, like changing our angles up a little bit, but our main adjustment was creating an x-axis out of duct tape. We used a color sensor, which is on the bottom of the rover, which senses this blue duct tape, and as soon as it hits this duct tape, the code says, okay, we've hit the x-axis, and resets the coordinate grid so that x is, or y is equal to 0.
So once it reaches the x-axis, it takes that x-coordinate and goes back down to the corresponding y value on the graph, and then it repeats the function from there. So it draws another tangent line and goes back up to the x-axis until the iterations is done, and that will be its approximation for the zero of the graph.
We think this rover can be really useful in classrooms because Newton's method is one of those mathematical concepts that is inherently visual, and we think it's very helpful for students to be able to input their own functions and see how Newton's method is actually being calculated.
So the first problem that we encountered was that the rover has a slot for a pen to go in, or in this case, a marker. But the issue is that pen is always on the ground. So whenever we move the robot, it's drawing a line. But sometimes we want to move the rover from one spot to another without drawing a line.
So we wanted to look at a modification to make the pen move up and down. So immediately I thought, let's use some sort of servo or some sort of linear motor that can lift something up and down. And while looking at the rover, it might be kind of scary seeing there's not a lot of places to connect things to. You have to get creative on what screw holes you can use. So what we ended up doing is we found that in the circuit board there was 2 screws holding it in. We utilized these 2 screws to add a 3D printed part on.
We designed this 3D part to fit into the 2 screws that were already in the board, so we wouldn't have to really physically modify the frame of the rover if possible. We designed it in CAD software to screw into the bottom and then have essentially just a rectangular slot for the servo to fit in. This is the servo that comes with the Innovator expansion pack, and it comes with a cable that plugs right into the side of the TI-Innovator hub that goes into the rover. And from there, you can easily program it to move in any direction you want.
Now, as daunting as it might seem, it looks like the pen is just taped on. Now, these are some sort of things you have to combat when playing with this rover. So for now, we just have it zip tied, but we plan in the future to make some sort of 3D printed piece that would actually attach to the pen. Now, another thing that we might run into is that we're modifying parts to the circuit board or having it fall off. So we added little grooves into this 3D printed part so that the screw would fit flat inside. Another thing that we did is that we actually took out this screw. We always made sure that this was loose because this is what holds down the pen. Now this is able to go up and down.
So the applications of a pen that can move up and down extend well beyond just demonstrating Newton's method. This was one specific case in which it was nice to be able to stop drawing a line, move to another location, then start drawing a line again. But being able to pick the pen up and off the ground will be huge for students and teachers who want to really draw any sort of artwork or math concept where you need to stop drawing a line for a while.